hand gesture. Hand gesture is a non-verbal communication between human and human 10 years ago, and now it's predominantly human to computer. So how do we make a computer understand hand gesture? So that's done using image processing. So image processing helps us. So what we basically do is we give vision to computer. So the vision is given to a computer using a camera, and teach the computer how to process the image, and then we get the recognition. So the process involved is conversion of the RGB, that is the color image, to grayscale. In grayscale, we smooth it out, and then we get the threshold out of the image, and then we do the convex hull, and then we do the fingertip detection. Too intense, right? I'll try to explain everything. Alright. Initially, we do the grayscale conversion to separate out the RGB component so that we deal with only two factors, the two values, that is either black and white. So that makes us easier for computation and easy for image processing. So the function here is used to convert the image which is received from the video, which is actually fed into a vector, and it's converted, flattened out to be a matrix. And then the final image output is image underscore gray. The function calls the CV underscore RGB to gray. We use opencv here to do that. The library opencv has the functions to convert image from RGB to grayscale. So after conversion of grayscale, we remove the noise. So if we have noise in the image, it will be not so easy for us to track the image. With the noise, the accuracy will be reduced. So we try to smoothen out the image, and we use Gaussian blur, the algorithm of Gaussian blur, to smooth out the grayscale image so that we get a smoothed image. And then we do the image thresholding. So what image thresholding does is, image thresholding separates the object of interest from the frame. That is, the object of interest in my project is my hand. So I try to separate it out from the background using the image thresholding function. So what we have here is the input image. After the Gaussian blur, we have the matrix, the image matrix in image gray underscore blur, and then the final would be put up in the image threshold, and the value, that is the 0 and 255. We are dealing with black and white, so we give the value 0 and 255, and the threshold underscore binary underscore inversion does, what it does is it converts white segments to black and blacker segments to white, so that the object of interest is displayed as white. So, so how does the computer understand that the object of interest is the particular color? So we have a different range of values in the grayscale. For example, we have 107, which is pretty much similar to this, and the 255 being white. So the highest the value is represented by white, and the lower the value, the darker it gets. So we have a range of values for in between the black and white segment. So after doing that, we try to find the envelope. That is, for example, we have points. We try to find a boundary using algorithm called convex hull. So what it does is it tries to find a boundary. That's my hand out there, and we are trying to find the total boundary of the hand. So after we find the boundary, we do the fingertip detection. So fingertip detection is done by convexity defect. So we have the edge outer points now. All we need to know is what are the other points which is required to subtract so that we can identify the fingers. from the image. So we may have a strange question like the convex defect on that point and the convex hull on this point can resemble a finger, but the maximum angle which we can have in our hand can be a possible 90 degrees. We cannot stretch our hand more than that, so that's an angle which is more than 90 degrees. So we also do the angle finding algorithm so that we have a range of angles. So we cannot stretch our hand so much that we cannot go on for an angle which is more than 90 degrees. So we compare the angle between two convex hull and a convex defect, and if it's in the range in between, we identify that as a finger. And the implementation is done using opencv, C++, and the platform is Ubuntu. So I'll give you some live